Some of you know him as Video Man. Some of you know him as a previous speaker here at LayerOne. He's going to be talking about GNU Radio, which is, I think you guys are going to get a kick out of it. I didn't know what GNU Radio was till about, I don't know, 6-7 months ago, and I started looking into it, and it's pretty cool. Everything from the ability to crack GSM and things like that, all the way up through just building your own transmitters. It's pretty neat. So, without further ado, here's David.
Great, thank you. Welcome. All right, so let's see, set up the slides here. All right, so how to have fun with wireless transmissions is essentially what GNU Radio, in my opinion, is. David Bryan, I'm an information security consultant. I've been doing security for 9+ years. CISSP, ham radio license, which don't tell the FCC that I'm doing this stuff, but because they might revoke my license. Anyway, hacker. I also do the network at DEF CON, and I work with Noid and the crew, so, or at least at DEF CON. All right. I apologize. This clicker is moving the slides too every once in a while. I don't know why, but so one of the things I wanted to say about LayerOne was that I think it's a really good thing that we're doing this. It's keeping the community strong. I think it's something that we need to continue to engage in and, you know, start to build these relationships with other people who are smart and figuring stuff out, because I think it will lead to a stronger community overall and a stronger security stance within our information security and within security in general. So I think that's great. And I also want to thank people who are doing hacker spaces. I think these are really great tools for people to come out and, you know, start working with hardware that they've never seen, or start playing on things that they've never played with. In this particular instance, we've got Mitch Altman. Has anybody heard of the TV Be Gone? So he's the creator of the TV Be Gone. He came to CCCKC, which is Cowtown Computer Congress of Kansas City. My wife and I drove down there from Minneapolis to hang out with Jurist and Mitch Altman for the weekend, and he did a workshop with about 20 people who had never soldered before, and it was just great. I mean, it was really fun to see all these people working on stuff like, oh, this is how I do it. So kudos to them, and, you know, if we can get more of these up and running, I think it'll be a really good thing. All right, so before I start the main component of the talk, I did a talk last week on lockpicks, bump keys, and hackers up in Minneapolis for our local security group up there. And one of the things that I included in the talk was essentially, well, talking about this. And so I just thought it was kind of neat from the perspective that, does anybody know what this is? Yep, a request to exit sensor. RTE is what they'll technically call it. But so essentially, I've always heard or been under the impression that, oh, you just take a Mylar balloon, you slip it under there, fill it with helium, and the door trips and it opens. I was like, nah, that can't be. Nah. So I actually went and tried it. I went to, well, I was out at a distribution center for one of our retail clients, and I went to the local store, picked up some tin foil, a rubber hose, some balloons, all sorts of fun stuff. And I also picked up a hot pack. And so basically I figured out that, let's see, oh, it's jumping around on me. All right, so I figured out that throw the hot pack in the microwave for 3 minutes, get a really long ruler and an envelope, stuff it under the door, and at some point, the door opens up. So, and it's basically that the sensor is looking for infrared. So, it was pretty fun. All right, so now on to my real topic, which is GNU Radio. Come on. There we go. No. All right, maybe I should stop using this. Anyway, all right, so countermeasures for that particular attack, I'm getting ahead of myself, is mind the gap. There's usually a gap under those doors that don't need to be there because installers are lazy. So, you know, either put some sort of a component to fill in that gap under the door, or disable the use of the request to exit sensor to either unlock that mechanism or trip the magnetic strike or de-engage the magnetic strike. So in a lot of companies, I've seen them put in push to exit sensors or push to exit essentially, and those work great. So do crash bars, which essentially is a physical mechanism again. So, all right, hacking with GNU radio. How many people here know what GNU radio is? Oh, good. We got quite a few people here. There's a few that maybe haven't had exposure to it, so good. So we're going to talk about what it is, what you need, some of the requirements for GNU radio, and then some of the costs. And then we'll also go into, after that, a sort of a attack that I did. So what is GNU radio? It's software. It's a software component with a hardware piece linked together. It's made out of C code and Python. The Python is where the users really get into making the changes to the code, and then it's compiled into bytecode, which runs very, very quickly and very fast on a lot of different machines. So, and it's very universal from that perspective. I don't know if anybody's worked with Python here. Yes, get a few head nods here. Yeah, okay. So Python is fast. It's it runs in memory. It's not. I mean, it is an interpreted language, but it's changed into bytecode before it's actually run, which is good. All right. So now on to the hardware. So the USRP is the hardware component. That's this thing sitting right here that works with the software. There's a couple things that are good to know. You probably don't need to know it once you start getting into it, unless you're doing some advanced stuff. But it's got an FPGA on it. It's got 4 digital to analog converters and 4 analog to digital converters. There's essentially what I would call 4 channels on the board. There's a transmit side A and a receive side A and a transmit side B and a receive side B. And then there's daughter boards from 0.1 megahertz all the way up to 5 gigahertz. Here's sort of the picture of it so you can see it a little bit better, hopefully. And then here's the motherboard, or the board component. You can see it's got a receive, a transmit, and a receive. And these are where you'd put the daughter boards in the A side or the B side. And these are the daughter boards. So we've got a basic receive. We've got, I think this one's a transmit. Oh no, it's anyway, 800 megahertz, 2.4 gigahertz receive. And then this one is a receive and transmit. I think that's the Flex 900, so that will do 900 megahertz. If I can't see from here, but anyway. So how can I use it? Obviously, we've got to get the hardware, the USRP. Now, I say install Ubuntu just from the perspective if you actually want to get it running with little pain. The first time I tried to install it, I actually started installing it on my MacBook. I got everything installed. I got all the dependencies, and 2 or 3 days later, I started going, all right, let's attach to this sucker. And then I shortly realized that my hardware didn't work with it because it was the first generation of the MacBook Pro, didn't have a USB 2.0 full-speed bus. The USRP requires that full-speed bus in order to be able to communicate back and forth. Or other Unix-like OS. If you do another Unix-like OS, you're probably going to go into dependency hell, and it can be very time-consuming to get all the dependencies compiled together in order to start playing with it. And at some point, you might give up and move on. Although if you spent the money on the hardware, you probably won't. But anyway, so the first one obviously requires USB 2.0. The second version, which just came out, I think he just posted to the website this week, is version 2, and it actually has a gigabit Ethernet on it, so you can have faster bus throughput. Essentially, it runs a protocol on top of that Ethernet to talk back and forth directly to the controller. All right, so why should I use it? Wireless signal generation and receiving. It's not necessarily restricted to any one frequency. when you go through and actually put together a circuit, an oscillation circuit, it can be kind of a pain in the butt. From the perspective that you got to design the circuit, you got to transfer it to a physical board, you got to put it together. Your prototyping can take a long time in order to get a wireless protocol put together, and your oscillator also has to go into that circuit, and a bunch of other stuff. However, with the USRP, it's very quick to prototype. You write a block of code that is your frequency modulation or demodulation, or however you're encoding your signals, and boom, you got it wedged into a data stream between you and another USRP. All right, so cost. The version 1 was $700. It still is, or it is $700 now. I think it was a little bit more, but version 2 is $1,400. So I don't know why these are so expensive. In my opinion, they should be cheaper. I would like to see them get down into the $500 range so that just about anybody can get them. However, that said, as I was doing the research, I found that a lot of people were saying that if they wanted to get a GSM oscilloscope or some sort of GSM test equipment, they were in the $20,000 to $30,000 range. So, yeah, if you can get the USRP, if you can scrape the money together, it's going to be a lot cheaper. It may not be as powerful, but I think it's still pretty good. So daughter boards, screws, case. Yeah, the biggest thing here, this last one, is it's not specifically FCC part licensed. So that means, does anybody know what part licensed means here? I got a couple here that know. Yeah, well, so there's part 15, but specifically in radio transceivers, anything that transmits, the story is that, so my wife and I go to DEF CON, and we have Yaesu radios that we've modified to transmit on other frequencies, although I will not admit that outside of this room. But that means that it is it's a non-compliant device now. It's not part of that FCC part license. She actually wanted to use our radios in search and rescue. She does search and rescue. It's an expensive radio. The search and rescue radios are expensive. Unfortunately, she couldn't specifically use it because then it would be outside of the part license. And if the unit ever got called into question, yada, yada, yada. All right, fine. So that's where that part licensing gets into play here. If it's not part licensed, that means you can't transmit on those other frequencies. Or if it is part licensed, that means it can't do any other frequencies besides what it's licensed to do. It's kind of goofy. They own the airwaves. They can do whatever they want. So it's really nice that you can essentially have a low power transmitter that is not part licensed, because you can oftentimes put bigger transmitters beyond that. So you can do fun things like owning your neighborhood's data, right? Priceless. Anyway. All right, so what can we do with it? We can fight. Come on, change. Anyway, wireless attacks. So in the past, there's been a couple of RFID attacks. There's been GSM attacks. Recently, there's a Bluetooth frequency hopping attack, and then MAS, which is what I kind of am going to talk about. So the RFID attacks, reading the tags. There was recently last year the Boston subway hacks, which are actually just a MyFair based RFID card system. So that came from the London system, essentially. The London hackers did the MyFair system previously. And then there's also the fact that you could do long-range tag reading. Essentially, you load up a lot of energy on your transmit, and ideally, you're going to have a lot more energy coming back from that tag. Simple physics. So that, one of the things that people have always said, oh, well, you can't read my tag because you have to be next to me. Well, that's not true. You can be just about anywhere, well, within line of sight. So GSM attacks, wiki.thc.org has a whole set of codes on A5 GSM cracking. Oh, airprobe.org. All right, there we go. So the other thought I had is there is GSM code in the GNU radio source code, create your own base station. You know, essentially you could have call routing. I mean, you know, that's a pretty cool thing. Or just have a call-free zone where you DOS all your friends. You know, I'm happy with that. Stop answering your phone. Anyway, Bluetooth attacks. So everybody know what frequency hopping spread spectrum is? There's a few. All right, I get more. Okay, so frequency hopping is essentially where it will hop between a set number of channels to some degree. It's pseudo-random, and it's based on the devices themselves. And it's been very hard to follow because you don't know where it's going to be until you've already seen it, and then it's moved from once you've seen it, it's moved on. Essentially what they figured out, what some people figured out is, actually this was presented at ShmooCon, and there was a DC 4420 meeting that presented the blue sniffing attacks. They figured out, oh, we'll put a bunch of USRPs together and basically just dump the whole spectrum, and we'll follow on one where the transmit has happened, essentially, and come back and decode the audio stream and inject into it and do all sorts of nasty stuff with the Bluetooth communications. So I think that's pretty cool, and I would love to see more of this expanded on. I don't have the time necessarily, but it'd be fun. All right, so MAS, has anyone heard of this? Multiple access system? All right, I got one here. Do you work for a utility? Oil and gas company. I won't tell. So in this particular instance, I was hired by a company or a utility to assess the security of this MAS system. I had a set number of hours to work on the project, so I didn't get into the decoding of the data, but you'll see what I kind of figured out. I figured out that I did a search on the frequencies that they're using, the major frequencies, and found this IEEE article from 1992 about, oh, this is, you know, supervisory controls, yada, yada, yada. Essentially, it's a really simple repeater type system where you'll have a head end that will be your utility management system that will talk to a repeater, and then that will repeat out to the other sites. And so, like, in this particular case, let's say I wanted to check the status of, you know, the watermark on a pump. So I would send my input frequency into the repeater. The repeater would then transmit it out to all the other stations. All the stations would hear it, and one of them would go, oh, that's my ID. I better respond. It would stop transmitting. The remote station that's supposed to call back in and say, all right, you know, my water level's at 500 feet or whatever it is, would then start transmitting on the repeater, hit the repeater, transmit back out to all the stations. And anybody who's listening within that area on its water level status or admin status or pump status or whatever it is. All right, so I thought, you know, that's kind of interesting. What could I do with this as an unauthenticated user? Could I maybe take over the repeater? I mean, oh, but I'd have to have a part licensed system for that, right? Thus comes GNU Radio, the USRP. So I thought, all right, I'll try bringing it up. I mean, it's very simple. This is a really simple attack. I'm just bringing up a carrier frequency with some audio on it onto that repeater's input frequency. So in typical repeaters, you have an input frequency that's what you're transmitting to the repeater, and then there's a different frequency. In this case, it was, you know, 928 megahertz something 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 and 952 something something something. And so the output frequency would then, you know, transmit all the commands. I thought, all right, I'll do that. So I grabbed the little antenna that comes with the kit, you know, drove up near the water tower, transmit. This doesn't work. That's kind of weird. Call into the radio operators and nothing, or the tower operators. All right, so nothing. So the next thing I did was, all right, we'll get a bigger antenna. This is my ham radio antenna. Yes, it should work. It's maybe not tuned to the 900 megahertz frequency, but you know, it's a big antenna, and I think it's maybe a 5 decibel gain or something along those lines. It should be good. Alas, no. I still didn't get it to trip. So I'm like, this is bull. And so I've only got a 200 milliwatt output power on my USRP. So I would have to get a linear amp or something, or maybe an antenna that's much, much bigger. So I did that. I went and stood outside the tower, and lo and behold, oh, comm fail, comm fail, comm fail, comm fail, comm fail. So essentially, I brought down the SCADA network by just bringing up a carrier frequency. I'm not saying that this hack is elegant, but I am saying that this is wrong. These networks need to be a much higher availability, higher integrity, in my opinion. So, you know, essentially, I overpowered the transmitter. I think I probably was transmitting about 1 watt overall, which is actually really low considering what I was actually hitting. So, but it worked. Got the comm fail, and moved on and said, hey, you know, you probably should do some different network. There we go. Different network attack or different networking for this. You know, it's a wide open system. No authentication, no encryption, no integrity. Again, it's that single in, multiple out type repeater. When you're using those, you know, obviously there's congestion or potential for congestion in this instance. I just think it was a poor design. It wasn't designed very well. It was designed, you know, back in the early '90s when, hey, the SCADA stuff, we gotta use our radios to transmit this data back and forth. Typically, or prior to this, they would used dry pair lines or modem lines or some sort of, you know, really expensive 56K frame relay or something along that lines. And they went, hey, you know, for $10,000, or maybe not 10, maybe 100,000 or whatever, you can put this up. You'll never have to change anything in the next, you know, 50 years, and you'll just pay FCC licensing fees, you know, every 10 years for those frequencies that you're using. And nobody else can transmit on those. All right, so some of the fixes, in my opinion, would be, you know, using encryption and having some sort of authentication or authorization to transmit on those frequencies that are built into the software, not just using the actual frequency to have the security in the environment. The other thing that would be kind of cool would be to use some of the mesh networking technologies with 802.11. I mean, if you could have your utilities having multiple sites that are linked together, if one of those links goes down, it would be self-healing, or at least that would be the concept, is it would route around the outage. Another one is out-of-band management. You know, I think there's enough internet connectivity in a lot of cities that you could drop in an out-of-band management that wouldn't be this radio transmitter. Of course, there's also enough utilities that are way the hell out in BFE where you can't get to, and that's where the radio comes in. Well, you know, use a better technology to manage that in that radio station. All right, so we're going to do a quick demo here. Hopefully this works. I've tested it a number of times, but you never know. So the first one we're going to do is an oscilloscope. Has anyone seen or heard of an oscilloscope before? I'm sure most people here. Hopefully, if you've got an electronics background, you've seen or heard of it. Takes a moment. That or it's on another window. There we go. All right. So there's our oscilloscope. It's going nuts. There's something transmitting here. You wonder what? What could this be? And it's taken up so much CPU now that it's crapped out. It happens sometimes. Yeah, DDoS on my own box. All right, so now, let's see, the next one here, oh, this one here. This one is actually a really cool view. Pretty, very pretty. So this is essentially something that's transmitting here, and you can kind of see it. What I would call it a histogram, essentially, where this is essentially the spectrum back and forth here, and something's transmitting on this spectrum. Boy, that's a lot of traffic. Maybe we'll once we identify it, we'll come back. All right, so exit out of this. All right, so it's out of sync, but yeah, let's try going to well, I don't know if you can see this or not, but can you kind of see that there's a picture there? Kinda. I didn't have time to write the decoding software for this, unfortunately. But so essentially, we've got a camera here. You can kind of see that there's a picture now, and you kind of it's not perfect, that's for sure. But obviously, you can identify the fact that hey, something out there is transmitting. So now let's go back to the spectrum. This guy, the waterfall spectrum, right? Going, whoop, gone. So it does a really good job of showing, hey, there's something on these frequencies right here. This is supposed to be set up for 906 megahertz. Here, I can show you. Plug it back in. Boop. Lots of noise. So. Yeah, unfortunately, there's no water utility around here that would allow me to demonstrate today. So anyway, and I don't want to get in trouble with the feds. Contracts are good. All right. Any questions on that one? Anything you're wondering about that? I got one back here.
Okay, so when you were looking at the spectrum analysis, that camera, even though it's pretty much specific frequency, appears to be kind of glossing over the spectrum. When you disconnected it, you saw stripes that were obviously transmitting one particular frequency.
Yep.
Why was it eating up everything?
It's a 10 megahertz bandwidth. So yeah, it goes 5 megahertz below and 5 megahertz above when it transmits its video. So it's a color video camera, and it does have audio with it as well. Although I couldn't find the audio channel, which is kind of frustrating. I bought it, I came into town Thursday and went to Fry's and Friday morning and bought it. So I was like, hey, this might be kind of fun to show at least some sort of idea of what you can do with the spectrum analysis and those types of tools. So there's another question over here.
You know, I was going to ask about like RF shielding with multiple daughter cards.
So the question is, have I used RF shielding with multiple daughter cards? Or is it required even? Well, I don't know that it would be required because it literally comes out of the socket. The transmit wire comes out and then gets ported into the front here. I only have one transmitter in this box, so I can't say specifically. Has anybody else worked with USRSPs here? No? All right. But that's a good question. I don't know. All right, so how can I contribute? This is one of the things that I want to see people contribute with this project. I'm kind of frustrated with the perspective that you go out and you're like, hey, I created this Python script for this TV stuff, and 3 years later, it still says in the code, I should come back and create the video decodes for this. I'm like, what? why haven't you guys done this? So I want people to play with it. I know that I think it was NoiseBridge that's got stuff up on their wiki about the USRP. NoiseBridge is up in San Francisco. I would assume that they would probably be willing to let people play with their USRP. You know, maybe put up a box somewhere and have the radio available for people to hack at it. You know, test their code, because it is an expensive box, and I might even say that that would be a really good thing for me to do. I've got this thing. Why not stick it up so people can play with it? So post about what you've done and what you plan to do, and see, you know, make sure that everybody sees your code. That's the biggest thing, is people write the code and then they forget about it and move on to the next thing. It'd be nice to have more people posting stuff about this. Play with it, obviously, and have fun. I had fun with this one. It was a little frustrating from the perspective that, you know, I was on a set timeline. I don't know, does anybody else here ever do fixed bid type contracts? Yeah, so you know how it is. It's like if you have 40 hours to do the project and you go over that, it's not good. Yeah, so I went to the least common denominator. Hey, I know I can bring up that repeater. And from there, it's just knowing that you can do that. You can now start to decode the packets. And in this case, so I talked with the engineer after the engagement and said, all right, you know, this is really kind of messed up. He said, yeah, but we do have some fail-safes in place unless you can turn on maintenance mode. So the thought is, oh, if I can figure out the protocol and how to forge it, I can turn on maintenance mode, which shuts off the pumps. Because all right, so I should explain that essentially what will happen is it's a self-contained system. If it loses connectivity with its head end, it'll just, you know, turn on the pumps at 3 o'clock in the morning, fill up the water tower, do its thing, and then set it to a certain water level and shut down the pump. If it's in maintenance mode, it won't do that. So if it's in maintenance mode, I can then turn the pump on and leave it on because it's in maintenance mode. Anyway. All right, so thank you folks for coming. I guess before I fully sign off, I want to take questions, but I wanted to thank my wife, Heather, Noid, the LayerOne crew. They've done a fantabulous job of putting this together over the last couple of years. And then my company for flying me out here, and LayerOne. So, questions?
Do you know if the radio has been used to interface with commercial radios like freeways or stuff that you currently see in this data environment?
So the question is, has the radio, the USRP, or?
No, like in the radio software,
have I seen?
Or have they used it to control like the commercial radio?
Not yet. So the question is, have they seen it to use, or has GNU radio been used to control commercial radio stuff yet? I personally haven't seen it. I don't know if anybody else in the room has or hasn't. I think it's, you know, it's kind of that gray area where it's really a prototyping tool, and they'll take that prototype and then put it into a commercial product later on. At least I think that's the concept behind it, is you can do the prototyping very rapidly. However, you can do the hacking very easily too. Yeah, you can bake it into an FPGA later on. Yeah, and you put it in, the firmware is on the one chip that you've made, et cetera, and you tested that it works and all that fun stuff.
Have you seen, or are there like plugins or content to let you do some of the protocol analysis on the signals that you receive, like if it's Modbus over TCP or something like that?
So they haven't. Well, I don't think they have Modbus over TCP, but they do have signal flow, what they call RBC, which is a block creation tool. So you can create the signal blocks and then write them to, you know, your Python script, and then have the Python get run on the FPGA to do the signal processing. So you can do some of that within the radio itself. As far as yeah, that was the other thing I was going to say. There are a couple projects that will take the output of a wireless protocol and dump it into Wireshark, so you could look at it. Yeah. no doubt. Yeah, specifically, this is just a physical layer tool. So that higher level Modbus protocol, ideally, Wireshark should be able to identify it. Go, hey, that's Modbus. All right. Any other questions? How am I doing on time? 11:05. Jeez. All right, so what do you guys want to talk about for the next 20 minutes? Does anybody else want to see anything with the USRP or have any questions on that one? Mm-hmm.
You mentioned the daughter cards of movement from 75 to 400. What are you looking at to actually acquire receive and transmit cards for, say, most of the spectrum?
So most of the spectrum, I think you can get a basic RX, and then there's a couple other the daughter cards that are about $75 a pop. The $400 card, I think, was the 2.9 or 4 gigahertz and up. It was very specialized, like microwave stuff, and I think that's why it's so expensive. But the cheaper cards, so the cards I have in here, I don't have a basic RX, which will do like most of the TV stations, and it will do any sort of police bands, those kind of things. I have a 900 megahertz card and a 800 to 2.4 gigahertz receive. So the 800 to 2.4 gigahertz covers a pretty big spectrum, and then that basic RX covers another pretty big spectrum. And you will even do like TV, stuff like that. So you can get a USRP for about $1,000. I think I probably paid $1,100 or $1,200 for this guy. It's kind of expensive hardware, but very versatile. Yes, absolutely. And I didn't pay it; my company paid it. Thank goodness. But the question is: is there any chance that other manufacturers will get on the bandwagon? I highly doubt it, because it's pretty risky for them. Because Matt Edis, or Edis Research, who is the guy who makes the USRP, he makes them himself. I mean, he's just a couple person company. Yeah, the specs are, but yeah, you could build your own, absolutely. But I don't know that I'd want to go through that process. It'd be pretty painstaking to try and develop your own board. I mean, you could do it, absolutely. More power to you. Anyway. No, I think that would be really cool if other people would come along and build that equipment, because then you could have an alternative that would be cheaper, ideally. Maybe it doesn't come with all the features that the USRP has. Maybe you only have one channel or one side instead of two sides. So. Should we bring up the spectrum analyzer again? All right. Sweep some space. All right. So, where'd that go? The USRP? So, the programs I wrote? It's pretty lame. I didn't write anything. Yeah. So there's actually, the program that I used was the push-to-talk FM, narrow FM, narrow FM transmit. I can show you that. Hold on. There is a lot of code here. So, user local, share, GNU radio, examples. In here, USRP. And it's this USRP narrowband FM push to talk. This is the code that I used to transmit. So, I mean, it's basic Python. It's I don't know how many. Talk. We're talking 497 lines of code. It's pretty small. Here, we can run this. And anybody want to transmit on some frequency? Does anybody know any good 900 megahertz frequency? Jeez. All right, so we'll say 902 megahertz. I don't know. Oh, no, I got to be root. So here's the basic interface that I used. I just brought it up, put it on the frequency, and went boop. Hit the space bar, which then it essentially transmits. That was as complex as I made it. It brought the system down. What's that? That's what brought the SCADA system down. I'm just bringing up a carrier frequency with some audio on it. Yeah, exactly. It's simple. It's so simple that I was like, I just gotta attack it this way. You know, if I do anything more complex, I'm going to be spinning my wheels, probably not making a lot of headway. So
in the environment, just give you a little background. So you caused the comm fail. So all the callouts died on that network. For every SCADA environment I've been in, that means that now the company's going to have to send out 50, 200, 500 people to monitor those stations individually to keep the pumps from being shut down either in maintenance mode or faulty, overflowing. In an oil and gas environment, you can shut a pump in, you can dispose of your water improperly, and get an environmental fine that'll run you a few $100,000 or whatever else.
And I take it they fail closed, so they have to be
There's no default state on how it fails. All these manufacturers decide how it fails. Because everybody does SCADA differently. That was the problem with SCADA.
Yeah.
Every company developed it on their own. So that little simple attack that took out the water network, you could cost the company several $1,000s per hour on that, or city in this case.
yeah, I mean, if they can't get water to their residents, or if they, or if you're working in, I've also worked in like nuclear facilities, nuclear power plants. And that's pretty scary because they have to take readings of everything before they release it. If they release it and they don't get a reading on it, they get fined. If they don't release it within a set amount of time, or if they don't take the reading properly and then report it, they get fined. I mean, the NRC, the Nuclear Regulatory Commission, is actually really strict, which is good because I would rather have that than, oh, we'll just release this water. Thanks, Homer. Don't. Well, here, let's bring up the spectrum analyzer here. The waterfall, which I think it's really pretty. I don't know. Anybody know any other good frequencies? So yeah, we got a pretty good red bar here. Somebody else transmitting here? It could be. I doubt it though. Blah 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 blah. Test. No. Oh, am I being booed off stage already? Jeez. Yeah, this one doesn't have a slider with it. So we could take the waterfall mode off. And it will give us pretty little graph lines. And then from there we can see, okay, this is 905 megahertz, 905.4, et cetera, et cetera. And we can even go out. Oh, that's the, yeah. We can make this bigger. I don't know what do you think these are? These are probably operating in the ISM, the Industrial, Scientific, and Medical band, the handheld radio devices. Yeah, that'd be kind of fun to transmit on. Maybe we should try that for later on in the day here. Whoa. Oh, it is? I may be able to tune to that. No, I can't. I think I can go down to 800, and that's as low as I can go. At least with the two daughter boards that I have. But with the other cards, you can go down to that. Again, it's not FCC part typed, which is really cool. All right.
So they kind of just tolerate it.
Yeah, well, it's such a low transmit power.
You can monitor anything you want, just transmission rate.
Yeah, exactly. Although, yeah, even the cell stuff isn't blocked, which I thought was kind of surprising. So, there's a hand back there.
Not super familiar with this stuff, but one of the first slides you put a slide up saying you could do something with a GSM A5. Saying you could use that to like sniff the GSM traffic and then decode it and listen to the stream.
Correct the GSM traffic. Yep, exactly. Yeah, that's wiretapping. So you're crossing the legal lines. But yeah, unless you're wiretapping your own call, apparently. At least that's what people have said. I don't know if that's true, but right. It's a shared medium. But yeah, so the A5 code has been cracked for a while now, and you can use the code that's out there already to do that. So yeah, it's pretty slick. Load it up and go. Yeah, GPUs to do it even faster than the USRP. So, all right. I think I'm going to call it, unless other people have questions or want to see other things. I mean, I can go through all the different interfaces of this. And if anybody wants to stop by, I'll be running around the con. I can maybe set up in the other room and have a laptop and people could play with it and see what it is. And I can open up the case and whatnot if people are interested. So, cool. Thank you, guys. Appreciate it.